Welcome to Saturn's realm. Welcome, settle in, get comfortable, and prepare for a journey to the most magnificent moon family in our solar system. Tonight, we're traveling to Saturn, the ringed giant, the jewel of our cosmic neighborhood, and the undisputed Moon King. With 274 known moons orbiting in its gravitational embrace, Saturn rules over the largest and most diverse family of worlds we've ever discovered. Over the next 2 hours, we'll visit these moons one by one, exploring ice worlds with hidden oceans, moons that spray water into space, ancient surfaces that preserve 4 billion years of history, and strange tumbling fragments at the edge of Saturn's realm. Each fact has been carefully woven into a gentle, flowing narrative designed to carry you peacefully towards sleep. If you enjoy tonight's journey through Saturn's kingdom, please take a moment to like this video and subscribe to the channel for more relaxing cosmic content. Your support helps us create these peaceful explorations of our universe. Now, close your eyes, breathe slowly, and let yourself drift towards Saturn and its magnificent family of moons. Our journey begins. Saturn, the Moon King. Drift with me now into the vastness of space, where we journey to a realm of ice and wonder, a kingdom unlike any other in our solar system, far beyond the familiar glow of Earth, beyond the rust-red deserts of Mars, and past the swirling storms of Jupiter. There exists a planet crowned with rings of ice and rock. This is Saturn, the jewel of our solar system, the ringed giant that has captivated humanity since the first moment we turned our eyes toward the heavens. But Saturn's beauty extends far beyond its magnificent rings. For this ancient world rules over something truly extraordinary, a vast family of moons, the largest collection of natural satellites orbiting any planet we have ever known. Picture, if you will, the number 274. It's a number that might seem abstract at first, just digits on a page. But 274 is the number of known moons that dance in their eternal waltz around Saturn. 274 worlds, each one a unique creation of cosmic forces, each one following its own path through the darkness of space. Saturn has 274 confirmed moons in its orbit, more than any other planet in our entire solar system. It is, without question, the Moon King. To truly grasp the magnitude of Saturn's celestial family, we must pause and consider what this number really means. Imagine standing beneath a clear night sky, looking up at our own moon, Earth's singular companion, the one celestial body that has inspired countless poems, songs, and dreams throughout human history. Now multiply that by 274. Saturn doesn't have just one moon watching over it. It has an entire population, a whole community of worlds, all bound together by gravity's invisible threads. The remarkable nature of Saturn's moon count becomes even clearer when we compare it to the rest of our solar system. With its 274 known moons, Saturn possesses nearly twice as many moons as all the other planets in the solar system combined. Let that sink in for a moment. Nearly twice as many. If we were to gather every moon orbiting Mercury, Venus, Earth, Mars, Jupiter, Uranus, and Neptune, and count them all together, Saturn would still reign supreme, its family of moons outnumbering all the others by an astounding margin. When we look specifically at Jupiter, that other gas giant, that massive world that once held the title of having the most moons, we see Saturn's dominance even more clearly. Saturn's total of 274 confirmed moons is nearly triple Jupiter's count. Nearly triple. And doesn't stop there. Saturn's moon population exceeds the combined number of known moons around all the other planets. Every moon circling every other world in our solar system, all added together, and still Saturn has more. This is the realm we're exploring tonight, a realm of abundance, of celestial richness beyond compare. Saturn isn't just a planet with moons. It's a planet that has fundamentally reshaped our understanding of what a planetary system can be. With its 274 moons, Saturn not only surpasses Jupiter, but it has more moons than are currently known around all the other planets combined. The Moon King, indeed. But as we settle deeper into our journey, as our breathing slows and our minds begin to drift through this cosmic landscape, we must understand something important about these 274 worlds. They're not all alike. Far from it. The family of Saturn's moons is as diverse as it is vast, a collection of individuals rather than identical copies. Of these 274 known moons, only a small fraction are what we might call large. In fact, just 13 of them are bigger than about 50 kilometers across. 13 substantial worlds, large enough to have been shaped by their own gravity into more rounded forms, large enough to have their own geology, their own stories written in ice and rock. These are the major moons, the ones that draw our attention, the ones we've named after titans and giants from ancient mythology. But what are the others? What are the remaining 261 moons? Most of Saturn's 274 moons are small, genuinely small, many only a few kilometers across. Imagine a moon you could walk across in an afternoon, a tiny world where you could see the horizon curving away in every direction, where Saturn would loom overhead like an impossibly vast painting stretching across the entire sky. These diminutive moons are fragments, pieces of a larger cosmic puzzle, each one a testament to the violent and creative processes that shaped the Saturn system billions of years ago. The size range of Saturn's moons is truly staggering, almost difficult for the human mind to fully comprehend. At one end of this spectrum sits Titan, Saturn's largest moon, a world so massive that it's actually larger than the planet Mercury. Titan is a giant among moons, a place with its own thick atmosphere, with lakes and rivers of liquid methane, with weather and seasons and a landscape that might, in some distant future, harbor life. Titan is a world unto itself, a planet in all but name. And at the other end of this incredible range, we find moons that are only a few hundred meters across. A few hundred meters, less than the length of a typical city block on Earth. These tiny moonlets are barely more than boulders, cosmic pebbles caught in Saturn's gravitational embrace. And yet, they are moons nonetheless, each one orbiting the great ringed planet in its own unique path, each one part of the grand symphony of the Saturn system. Between these extremes lies every variation you could imagine. Saturn's larger moons, those substantial worlds like Rhea, Iapetus, Dione, and Tethys, are roughly spherical, shaped by their own gravity into the smooth, rounded forms we typically associate with planets and moons. When we look at images of these larger moons, we see worlds that look familiar somehow, even though they're composed primarily of ice rather than rock. They have the dignified, balanced appearance of celestial bodies that have settled into their final forms, their surfaces marked by ancient craters and icy cliffs, but their overall shape comfortingly round and regular. But many of Saturn's smaller moons tell a different story entirely. These are irregularly shaped worlds, lumpy and asymmetrical, each one a unique sculpture carved by chance and collision. Some of these small moons look remarkably like potatoes, elongated, bumpy, with irregular bulges and indentations that give them an almost organic appearance. Others resemble meatballs, nearly spherical but textured and uneven, as if they were hastily formed and frozen in place before gravity could smooth their surfaces. And then there are the truly strange ones, moons that look like sponges, riddled with craters and cavities, their surfaces so heavily impacted and eroded that they seem fragile, almost delicate, despite being made of ice and rock. Each of these shapes tells us something about the moon's history. The irregular forms speak of violent origins, of collisions and fragmentations, of pieces broken off from larger bodies or captured from passing debris. They remind us that the Saturn system, for all its beauty and order, was born in chaos, shaped by countless impacts and near misses over billions of years. And so, as we prepare to journey deeper into this realm, as we ready ourselves to explore individual moons and their unique characteristics, we must always remember this fundamental truth. Saturn's moon system is the largest and most diverse in the solar system. It is a kingdom of ice and rock, of giants and fragments, of ancient, cratered worlds and tiny captured asteroids. It is a place where every moon has a story, where every orbit conceals mysteries waiting to be discovered. This is the realm of Saturn, the Moon King, ruling over 274 known worlds. And tonight, as you drift towards sleep, you'll visit this kingdom, one moon at a time, one wonder at a time, letting the vastness of space and the ancient silence of these distant worlds carry you gently into dreams. Rest now. The journey has only just begun, and there are so many moons waiting to share their secrets with you. Breathe slowly. Let your thoughts drift like moonlight, and prepare to continue deeper into Saturn's magnificent realm. How we found so many moons. Settle deeper now, as we turn our gaze not to the moons themselves, but to the patient work of discovery, to the human story of finding these distant worlds. There was a time, not so very long ago, when Saturn's family seemed much smaller. Just over a decade ago, astronomers counted 62 known moons orbiting the ringed planet. 62 worlds, still an impressive number, still enough to make Saturn remarkable among the planets. But 62 was only the beginning. In the years that followed, through countless nights of observation, through the careful analysis of thousands upon thousands of images, through the dedication of astronomers around the world, something extraordinary happened. That number grew and grew and grew until finally, astronomers increased Saturn's moon tally from just 62 about a decade ago to 274 today. 274. From 62 to 274 in roughly 10 years. It's an astronomical explosion of discovery, a testament to both improving technology and the persistence of those who study the night sky. But this growth didn't happen all at once, in a single moment of revelation. No, it unfolded in stages, in waves of discovery, each one adding to our understanding of Saturn's magnificent realm. The story of recent discovery really accelerates in the year 2023. Before the most recent announcements in 2025, Saturn had already reclaimed its title as the Moon King, a title it had briefly lost to Jupiter in the ongoing friendly rivalry between these two gas giants. In 2023, astronomers announced that 62 new moons have been added to Saturn's count. 62 new worlds, all confirmed and verified, all real objects orbiting the Great Ring Planet. With that single announcement, Saturn leaped ahead once more, establishing its dominance in the solar system's moon census. But 2023 was not the end of the story. It was merely preparation for what came next. In March of 2025, just recently, in the grand scheme of cosmic time, astronomers made an announcement that would reshape our understanding of Saturn's system yet again. In that single month, in that single moment of scientific revelation, they announced 128 newly confirmed small moons around Saturn. 128, more than double the number discovered in 2023, more than double the total Saturn had possessed just over a decade before. It was a landmark moment in planetary science, a discovery that made headlines around the world and reminded humanity just how much we still have to learn about our own cosmic neighborhood. These weren't just casual discoveries, unofficial observations waiting for verification. The International Astronomical Union, the global authority responsible for naming celestial objects and maintaining the official records of our solar system, officially recognized these moons in March 2025. This recognition carries weight. It means these moons have been observed multiple times, their orbits calculated and confirmed, their existence verified beyond doubt. They are now part of the official census of our solar system, recorded in the astronomical record books for all time. The formal recognition came on a specific date, one that will be remembered in the history of planetary science, the 11th of March, 2025. On that day, Saturn's official moon count jumped dramatically. Scientists around the world celebrated, knowing that their painstaking work had finally been validated, that their careful observations had revealed new worlds that would now be studied for generations to come. But how did this happen? How did astronomers find so many small, distant moons that had eluded detection for so long? The answer lies in a combination of new techniques, better technology, and above all, extraordinary patience. Many of these small outer moons were first detected in wide-field surveys conducted in the 2000s and 2010s. Imagine astronomers pointing their telescopes at broad swaths of the sky around Saturn, capturing huge areas in single images, looking not for individual moons, but for anything that might be moving against the background of distant stars. These wide-field surveys were like casting a net across the darkness, hoping to catch faint glimmers of reflected sunlight from tiny, distant objects. And they did catch glimpses, faint hints of objects that might be moons. But hints are not enough. In science, especially in astronomy, you need confirmation. You need to see the object multiple times, track its movement, calculate its orbit, prove that it's really there and not just an artifact of the imaging process or a distant asteroid passing through. So the work continued. Between 2019 and 2023, astronomers used a technique called repeated imaging. Night after night, sometimes over the course of months or even years, they would point their telescopes at the same regions of space around Saturn, capturing image after image after image. Each individual image might show nothing more than noise and starlight, with perhaps the faintest suggestion of something moving. But here's where the magic of modern astronomy comes in. These images, dozens, sometimes hundreds of them, were stacked together, combined using sophisticated computer algorithms that aligned the images and added their light together. When you stack images like this, something wonderful happens. The background noise, which is random and different in each image, begins to cancel out. But real objects that are actually there and moving in predictable ways, begin to accumulate light. They grow brighter with each added image. Suddenly, what was invisible in any single photograph becomes visible in the combined stack. Extremely faint moving points of light, tiny dots crawling slowly against the starry background. Each of those faint points was a moon, a real world, billions of kilometers away, so small and distant that its reflected sunlight reaches us as barely a whisper, a glimmer that challenges the very limits of our detection capabilities. But by stacking those images, by patiently accumulating photons over weeks and months, astronomers could finally see these hidden moons, could track their movements, could calculate their orbits, and confirm their existence. One facility played a particularly important role in these discoveries: the Canada-France-Hawaii telescope, perched high on the summit of Mauna Kea in Hawaii, one of the best observing sites on Earth. With its location above much of Earth's atmosphere, with its sophisticated instruments and wide field of view, this telescope was ideally suited for the patient, methodical work of moon hunting. Night after night, when weather permitted, it captured images of Saturn's outer reaches, contributing to the vast data set that would eventually reveal more than 100 new moons. The telescope stands there still, its dome a silent sentinel against the stars, continuing its work, continuing to watch Saturn and the rest of the solar system, ready to find even more moons when they reveal themselves. And they will reveal themselves. Because here's the beautiful, exciting truth that keeps astronomers motivated through those long nights of observation. Saturn's moon count is not final. Far from it. Because so many of Saturn's moons are small and faint, some only a few hundred meters across, some so dark they reflect barely any sunlight at all. Saturn's moon count is expected to keep growing. There are almost certainly more moons out there, waiting to be found. Tiny fragments of ice and rock, orbiting in the outer reaches of Saturn's gravitational influence, too faint to detect with current technology, too small to have been caught in existing surveys. As our telescopes improve, as our image processing techniques become more sophisticated, as astronomers continue their patient work of repeated imaging and careful analysis, more moons will emerge from the darkness. Perhaps next year, there will be an announcement of 10 new moons, or 20, or another 100. The discoveries will continue, each one adding to our census of Saturn's realm. Each one a reminder that even in our own solar system, in a region of space we've been studying for centuries, there are still surprises waiting. For now, though we rest with the knowledge that 274 moons orbit Saturn, each one confirmed and verified, each one a real place in space. And we celebrate the patient work of the astronomers who found them, people who spent years staring at faint points of light, who developed new techniques to tease signal from noise, who never gave up on the possibility that more moons were out there waiting to be discovered. The Moon King's family continues to grow, and as you drift towards sleep, you can take comfort in knowing that somewhere right now there might be a new moon waiting to be found, a tiny world reflecting sunlight in the darkness, patient, eternal, waiting for the moment when human eyes finally notice its faint glow and welcome it into the family of known worlds. Rest now. Let these thoughts of discovery drift through your mind like starlight, and prepare to meet the moons themselves, organizing the chaos. As we drift deeper into our journey, we begin to see patterns emerging from the vastness, an order hidden within what first appears to be cosmic chaos. With 274 moons orbiting a single planet, you might imagine the scene around Saturn to be one of complete disorder, a jumbled crowd of worlds moving in random directions, careening through space without rhyme or reason. But the universe, for all its violence and unpredictability, has a deep love of order. Gravity, that fundamental force that holds everything together, that keeps planets orbiting stars and moons orbiting planets, doesn't create chaos. It creates patterns. It creates structure. It creates harmony, even when that harmony is complex and difficult to perceive at first glance. And so it is with Saturn's moons. Despite their vast numbers, despite the incredible diversity of their sizes and shapes, these 274 worlds are not scattered randomly through space. They are organized, categorized, grouped into families based on where they orbit and how they move. In fact, Saturn's moons are grouped into 9 main orbital categories, 9 distinct families, each with its own characteristics, each telling us something different about how the Saturn system formed and evolved over billions of years. Think of these categories as neighborhoods in a vast cosmic city, each one with its own character, its own residents, its own story to tell. Some neighborhoods are close to the center, where the planet's influence is strongest. Others are far out in the suburbs, in the distant reaches where Saturn's gravity barely holds on to its wandering children. The first and most orderly of these neighborhoods consists of the inner regular moons, worlds that orbit close to Saturn's equatorial plane. Imagine Saturn as a spinning top, rotating around an axis, its equator forming an invisible disk extending out into space. These inner regular moons stay very close to that disk, orbiting in neat, circular paths that align almost perfectly with Saturn's rotation. They are the well-behaved children of the Saturn system, the moons that follow the rules, that move in predictable, stable orbits that will likely remain unchanged for billions of years to come. These inner moons include some of Saturn's most famous residents: Mimas, Enceladus, Tethys, Dione, and Rhea, worlds we'll visit in detail as our journey continues. But for now, as you settle deeper into relaxation, just picture them, a procession of icy spheres circling Saturn in elegant, synchronized paths, each one staying in its lane, each one maintaining a respectful distance from its neighbors. But not all of Saturn's moons are so orderly. Some have chosen more interesting arrangements. Consider this. Several moons share orbits as co-orbitals, occupying the same orbital path around Saturn, even though they are separate objects. How is this possible? How can two moons share the same orbit without eventually colliding? The answer lies in one of the most fascinating dynamical arrangements in the entire solar system, exemplified by two moons named Janus and Epimetheus. Picture two moons, both irregularly shaped, both roughly similar in size, both orbiting Saturn at nearly the same distance. At any given moment, one moon is slightly closer to Saturn than the other, just a few kilometers of difference in a vast ocean of space. The inner moon, being closer to Saturn, moves slightly faster in its orbit, following the laws of gravity that dictate closer objects must move more quickly to maintain their paths. So the inner moon gradually catches up to the outer one. Over the course of years, the gap between them slowly closes. They draw nearer and nearer, until it seems inevitable that they must collide. But they don't, because just before they would meet, something extraordinary happens. They swap orbits. Through a complex gravitational dance, the inner moon is pushed outward and slows down, while the outer moon is pulled inward and speeds up. They exchange positions, and the chase begins again in the opposite direction. Janus and Epimetheus perform this elegant swap roughly every 4 years. For years of pursuit, for years of the gap slowly closing, and then swap, they trade places and begin again. It's a waltz that has been going on for millions of years, a perfectly choreographed dance that will continue for millions more. As you drift towards sleep, you can imagine these two moons forever approaching, forever swapping, forever dancing in the darkness around Saturn. But the orbital complexities don't end there. Some of Saturn's mid-sized moons have what astronomers call Trojan companions at stable Lagrange points. Now, this might sound technical, but the concept is beautiful in its simplicity. Imagine a moon orbiting Saturn. Let's call it the main moon. This moon creates small regions in its orbital path, one ahead of it and one behind it, where gravity from Saturn and gravity from the moon itself balance out in just the right way to create stable locations. These are Lagrange points, and they're like gravitational parking spaces where smaller objects can sit, following the same orbital path as the main moon, but positioned 60 degrees ahead or 60 degrees behind. Several of Saturn's moons have these tiny companions sitting at their Lagrange points, like loyal attendants following their larger siblings around and around Saturn's equator. They maintain their relative positions through the subtle balance of gravitational forces, another example of the hidden order underlying the apparent chaos of the moon system. And then there are the resonances. Many of Saturn's moons are locked in orbital resonances with each other, gravitational relationships, where their orbital periods form simple ratios. For every 2 orbits one moon completes, another might complete exactly 3 or 4 or 5. These resonances aren't coincidences. They're stable configurations that the moons naturally settle into over time, locked together by gravity's invisible threads. These resonances might seem like mere mathematical curiosities, interesting patterns that astronomers enjoy cataloging, but nothing more. But they have profound physical effects. These resonances influence internal heating and geology of the moons involved. When moons are locked in resonance, their orbits can become slightly elliptical rather than perfectly circular. As they move closer to and farther from Saturn in each orbit, the planet's gravity flexes them, squeezing and stretching their interiors like a rubber ball being compressed and released over and over. This flexing generates heat, friction at the molecular level, warming the moon's interior, sometimes enough to melt ice and create liquid water oceans beneath frozen surfaces. Some of Saturn's most geologically active moons owe their activity to these resonances, to the constant gravitational massage they receive from Saturn and their neighboring moons. We'll meet these active worlds in time, but for now, just understand that resonances are the hidden architects of geological activity, the invisible forces that keep some moons young and dynamic while others grow cold and dead. The dance of Saturn's moons is not static. It is constantly evolving, though on timescales so vast they're difficult for human minds to truly comprehend. Tidal interactions, the same gravitational forces that create the resonances and the orbital swaps, slowly push moons outward over time. Every interaction between Saturn and its moons, every gravitational tug, transfers a tiny amount of energy. Over millions and billions of years, this causes moons to gradually spiral outward, moving farther from Saturn in an imperceptibly slow migration. Meanwhile, internal dissipation, the gradual loss of energy through friction and heat, reduces orbital eccentricities. Orbits that were once elliptical slowly become more circular. Energy is constantly being redistributed throughout the system, transferred from one moon to another, from Saturn to its satellites, from orbital motion into heat, in an endless cosmic accounting that has been going on since the system formed, and will continue until the sun itself grows old and dies. This is the profound truth we must understand as we explore Saturn's realm. Saturn's moon system is dynamically active, not static. It's not a frozen arrangement, a picture we can examine and say, this is how it is and how it will always be. No, it's a living system, constantly changing, constantly evolving. Each moon influencing its neighbors, each gravitational interaction writing the next chapter in a story billions of years old. The moons we see today are not in the same orbits they occupied when they formed. The resonances that exist now are not the same ones that existed a billion years ago. And the Saturn system we would see if we could return a billion years in the future would be different again, subtly, perhaps, but measurably changed by the patient work of gravity and time. So as you relax deeper, as your breathing slows and your mind begins to wander through these cosmic landscapes, remember this: you are witnessing a moment in time, a single frame in a 4 billion year long film. The moon's orbit, they interact, they dance, they slowly spiral outward. They exchange energy. They shape each other's orbits and heat each other's interiors. They live in their own slow, geological way. And above it all, Saturn watches, silent, majestic, its rings glittering in the distant sunlight, its 274 children spread out around it in 9 distinct families, each family with its own character, each moon with its own place in the grand cosmic order. Let these thoughts drift away now, like moons moving through space, each one following its path, each one part of something larger, something beautiful, something eternal. Rest and prepare to meet these worlds individually, to hear their specific stories, to learn what makes each one unique in Saturn's magnificent family. Titan, a world of its own. Now we arrive at a place unlike any other, a moon that is more than a moon, a world that stands alone in the solar system. Let yourself drift toward Titan. In the vast family of Saturn's 274 moons, one world stands apart. One moon dominates not just in size, but in complexity, in mystery, in its uncanny resemblance to a place we know well. This is Titan, Saturn's largest moon, a world so extraordinary that it challenges our very definitions of what a moon can be. When we speak of moons, we typically imagine small, airless rocks, cratered and dead, circling their parent planets in silent orbits. We think of Earth's moon, beautiful, yes, but barren. We think of places without weather, without atmospheres, without the dynamic processes that make worlds truly alive. But Titan is not such a place. Titan is Saturn's largest moon and larger than the planet Mercury. Let that comparison settle in your mind as you relax deeper. Mercury, a planet in its own right, one of the 8 worlds that orbit our sun. And here is Titan, officially classified as a moon, yet exceeding Mercury in size, outmassing it in volume, claiming a place among the true giants of the solar system. It is a moon that could have been a planet, a world that in any other context would demand to be recognized as something more than just a satellite. Titan has a diameter of about 5,150 kilometers. Picture a sphere stretching more than 5,000 kilometers from one side to the other, a globe so large that if you could somehow stand on one point of its surface, the opposite side would be beyond the horizon's curve, hidden by thousands of kilometers of ice and rock. This is not a small world. This is a place with continents and regions, with geography on a planetary scale, with enough surface area to contain landscapes as varied as any we find on Earth. And this massive world moves through space in a stately orbit. Titan orbits Saturn every 15.95 Earth days, just under 16 days to complete one circuit around the ring planet. A year on Titan lasting only 2 weeks by our reckoning. Imagine watching Saturn wheel overhead, growing from a crescent to full and back to crescent again, all in the span of a fortnight. Imagine seasons measured not in months, but in days, a world where time moves to a different rhythm than we know. But size alone, impressive though it is, doesn't make Titan special. What truly sets this moon apart, what elevates it to a category entirely its own, is something we take for granted on Earth, but which is extraordinarily rare in the cosmos. Titan has a thick nitrogen-rich atmosphere. An atmosphere, real air, thick enough to support weather, thick enough to scatter light and create a haze that shrouds the surface in mystery. When we look at images of Titan, we don't see craters and ice. We see clouds. We see layers of atmospheric haze, orange and gold, swirling around the moon like a blanket. This atmosphere isn't a thin whisper of gas like Mars possesses, barely enough to register on our instruments. No, Titan's atmosphere is dense, thicker at its surface than Earth's atmosphere is at sea level. If you could stand on Titan without protection, You would feel pressure all around you, the weight of nitrogen pressing against your body, just as our own air presses against us here on Earth. Nitrogen, the same gas that makes up most of Earth's atmosphere, the same element that cycles through our biosphere, that forms proteins and DNA, that is essential to life as we know it. On Titan, nitrogen falls from the sky as rain, though not the kind of rain we know, because Titan possesses something else, something that makes it unique not just among Saturn's moons, but among all the worlds we've yet discovered beyond Earth. Titan is the only world besides Earth with stable surface liquids. Read that again, slowly, letting the weight of it settle over you like a warm blanket as you drift towards sleep. In all the solar system, among all the planets and moons and asteroids and comets we've studied and explored, only 2 worlds have permanent liquids on their surfaces. Only 2 worlds have lakes that don't immediately evaporate into the vacuum of space or freeze into solid ice. Earth and Titan, but these are not lakes of water. On Titan, the temperature hovers around minus 179 degrees Celsius, far too cold for water to exist as a liquid. Instead, Titan's lakes and seas are filled with methane and ethane, hydrocarbons that exist as gases on Earth, but which, in Titan's frigid environment, condense into liquids. Imagine standing on a shore, not a beach of sand, but a coast of water ice harder than rock, looking out over a sea of liquid methane, its surface rippling in the gentle wind, reflecting the dim, hazy sunlight that manages to penetrate through the thick atmosphere above. And these are not small puddles. Titan has seas larger than North America's Great Lakes. It has a body called Krakenmeer that is larger than the Caspian Sea, stretching across hundreds of kilometers of Titan's northern hemisphere, deep enough to swallow mountains, filled with billions of gallons of liquid methane and ethane. These are real seas, with waves and tides, with shorelines that advance and retreat with the seasons, with everything we associate with terrestrial oceans except the water itself. Rivers flow on Titan. Rivers and shorelines shape Titan's surface, carving channels through the icy bedrock, creating drainage networks that look hauntingly familiar when we examine them in images sent back by space probes. These rivers meander across Titan's landscape just as earthly rivers do, following the contours of the terrain, joining together to form larger streams, eventually emptying into the methane seas. The Cassini spacecraft, during its years of studying Saturn and its moons, imaged these river networks in radar, seeing through the thick atmosphere to map a world that looked, in so many ways, like home. There are clouds on Titan, weather systems, precipitation. The methane that evaporates from the seas rises into the atmosphere, condenses into droplets, and falls back to the surface as rain, a hydrological cycle almost identical to Earth's water cycle, but driven by methane instead. Storms sweep across Titan's surface. Seasonal patterns emerge. The Northern Hemisphere experiences summer and winter, wet seasons and dry seasons, all driven by the complex interplay of sunlight, atmosphere, and liquid methane. And yet, for all this remarkable similarity to Earth, we must remember something sobering. Titan lies far outside the Sun's habitable zone. The habitable zone, that narrow band of distance from a star where temperatures allow liquid water to exist on a planet's surface, extends from roughly the orbit of Venus to just beyond Mars in our solar system. Titan orbits Saturn, which itself lies at nearly 10 times Earth's distance from the Sun out there. In the cold outer reaches of the solar system, sunlight is dim and weak, providing only 1% of the warmth that bathes Earth. This is not a place where life, as we know it, could exist on the surface. This is a frozen world, alien and inhospitable, despite all its Earth-like qualities. But here's where Titan reveals yet another secret, another reason to marvel at this extraordinary moon. Despite existing far outside the habitable zone, despite its frigid surface temperature, Titan likely has a subsurface liquid water ocean. Beneath the frozen crust of water ice, beneath the surface we've mapped and studied, there exists, almost certainly, a global ocean of liquid water, kept warm by internal heat, by the radioactive decay of elements in Titan's core, by the tidal flexing caused by Saturn's gravity. This ocean lies perhaps 50 to 100 kilometers below the surface, sealed away from the vacuum of space, protected from the cold, a hidden sea that might contain more water than all of Earth's oceans combined. This discovery, pieced together from gravitational measurements and orbital analysis, from the way Titan flexes and deforms as it orbits Saturn, has profound implications. It means Titan has two completely separate environments where, in theory, life could exist. On the surface, in the methane seas, something might live that uses liquid methane the way earthly life uses water, a form of life so alien we can barely imagine it, but not impossible according to the laws of chemistry. And deep below, in the hidden ocean, more familiar forms of life, microbes similar to those in Earth's deep oceans, might thrive in the dark, warm water, sustained by chemical reactions, never knowing the frozen world above. This duality makes Titan one of the most Earth-like worlds in the solar system, chemically speaking. Not Earth-like in temperature or in surface conditions or in the kind of life it might host, but Earth-like in its complexity, in its dynamic geology, in its possession of an atmosphere and weather and rivers and seas. Earth-like in having multiple environments where chemistry can do interesting things, where energy flows, where conditions exist that might just possibly support life. When the Cassini spacecraft arrived at Saturn in 2004, it carried with it a small probe named Huygens, designed specifically to descend through Titan's atmosphere and land on its surface. On January 14, 2005, Huygens separated from Cassini and began its descent, becoming the first human-made object to land in the outer solar system. For 2.5 hours it fell through Titan's orange haze, its cameras recording images of river channels and rounded ice boulders, its instruments sampling the atmosphere, measuring temperature and pressure, analyzing the composition of the air. And then it landed on what appeared to be a dry lake bed, a floodplain of methane-smooth pebbles. It survived for 72 minutes on the surface before its batteries died, long enough to send back a handful of images of a dim, alien landscape, rocks of water ice scattered across a dark plain, a hazy orange sky overhead. In those images, grainy and brief though they were, we saw another world. We touched, however briefly, a place as complex and dynamic as Earth, a moon that transcends the definition of moon and becomes, instead, a world unto itself. Titan waits there still, orbiting Saturn every 16 days, its methane seas lapping at icy shores, its atmosphere churning with storms, its hidden ocean lying silent beneath kilometers of frozen crust. It is a world we've only begun to explore, a place that demands return visits, that calls out for submarines to dive in its seas and drills to penetrate its ice and rovers to cross its plains. For now, though, it remains mysterious, beautiful, and strange, the crown jewel of Saturn's family, the largest moon in a kingdom of moons, a world that shows us how diverse and surprising the solar system can be. Rest now in this knowledge. Let thoughts of methane seas and nitrogen skies drift through your mind like clouds. And know that even in the cold outer reaches of the solar system, worlds exist that challenge everything we thought we knew. Enceladus, an ocean in space. Drift with me now to a smaller world, a world of ice and mystery, where water erupts into the darkness of space. Let us visit Enceladus. After the grandeur of Titan, after contemplating a moon larger than planets, we turn our attention now to something far smaller, far more delicate, and yet no less remarkable. In fact, what we're about to explore may be one of the most important discoveries in the history of planetary science, hidden within a tiny world that few people had heard of before spacecraft ventured to Saturn's realm. This is Enceladus, a small icy moon only about 499 kilometers across, not even 500 kilometers from one side to the other. A moon you could drive across in a few hours if roads existed on its frozen surface. A world so small that if you stood on its equator and looked up, you would see the horizon curving away sharply in every direction, the entire moon visible in your peripheral vision. Compared to Titan's vast expanse, Enceladus seems almost insignificant, a tiny ice ball lost among Saturn's multitude of moons. But size, as we're learning in our journey through Saturn's realm, tells us very little about a world's importance or its capacity to surprise us. Because Enceladus does something extraordinary, something that no one predicted before spacecraft cameras capture it happening. Enceladus sprays plumes of water vapor and ice into space. Imagine standing on this small moon's icy surface, looking toward the South Pole and seeing geysers erupting skyward. Not lava, not gas, but water. Jets of water vapor mixed with tiny ice crystals, shooting hundreds of kilometers above the surface, out into the vacuum of space, sparkling in Saturn's distant sunlight like cosmic fountains. These aren't small features. They aren't subtle. When Cassini first imaged Enceladus backlit by the sun, the plumes showed up as brilliant jets, clearly visible, undeniably active. Here was a moon, barely 500 kilometers across, actively venting material into space, proving that geological activity isn't limited to large worlds like Earth or Titan. Even a small moon, given the right conditions, can be dynamic and alive. The plumes erupt from tiger stripe fractures near the South Pole. When scientists examined high-resolution images of Enceladus's southern hemisphere, they discovered something strange. 4 parallel fractures, each stretching for more than 100 kilometers across the ice, glowing slightly warmer than their surroundings in infrared images. These fractures, nicknamed tiger stripes because of their appearance, are the source of the plumes. They are cracks in the ice shell, fissures that penetrate deep into Enceladus's interior, providing a direct pathway for water from below to escape into space. As you settle deeper into relaxation, picture these tiger stripes, long, dark lines scored across white ice, venting steam like the hot springs of Yellowstone or Iceland, except here there's no ground to walk on, no air to breathe, just the eternal cold of space and the distant glow of Saturn hanging overhead. But where is this water coming from? Why is it warm enough to remain liquid, to have enough pressure to erupt through the ice? The answer lies beneath Enceladus's frozen crust, hidden from direct view, but revealed through careful analysis of Cassini's data. Cassini data show Enceladus has a global subsurface ocean. A global ocean, not a small pocket of liquid water, not isolated lakes trapped in ice, but a complete ocean encircling the entire moon beneath its icy shell. Think of Enceladus as an egg. The shell is the frozen ice crust we see on the surface, perhaps 20 to 30 kilometers thick. The white of the egg is the ocean, liquid water, kept warm by tidal heating, sustained by the same kind of gravitational flexing we discussed earlier, the same orbital resonances that generate heat through friction and compression. This ocean is likely tens of kilometers deep, containing more water than some of Earth's smaller seas. It's completely dark, completely isolated from the sun, existing in a state of perpetual night beneath the ice. And yet, despite the darkness, despite the cold above and around it, this ocean is warm enough to remain liquid. Scientists estimate the temperature might be near 0 degrees Celsius at the base of the ice shell, right at the freezing point, but possibly warmer deeper down, closer to Enceladus's rocky core. And here's where the story becomes even more intriguing, even more profound in its implications for the possibility of life beyond Earth. The ocean may include hydrothermal vents on the seafloor. Just as on Earth, where we find hot springs on the ocean floor, places where heat from the planet's interior warms the water and creates chimney-like structures that spew mineral-rich fluid into the surrounding sea, Enceladus may have similar features. Data from Cassini, which flew through the plumes and analyzed their composition, detected not just water vapor and ice, but also salt, silica particles, and complex organic molecules, the building blocks of life as we know it. The presence of silica suggests that water is interacting with rock at temperatures of at least 90 degrees Celsius, the kind of temperatures you'd find at hydrothermal vents. The organic molecules suggest that chemistry is happening, that carbon-based compounds are being created and destroyed in ongoing reactions. This matters because on Earth, hydrothermal vents are oases of life. In the deep ocean, far from sunlight, where photosynthesis is impossible, entire ecosystems thrive around these vents. Microbes harvest energy from the chemical reactions happening where hot vent fluid meets cold seawater. Larger organisms, tube worms, crabs, fish, feed on the microbes, creating complex food webs that rely not on the sun but on the heat of Earth's interior. If Enceladus has similar vents, then these vents could create potential habitats for life. Not complex life, probably. Not fish or worms. But microbes, simple organisms that could survive in the dark, warm water, feeding on chemical energy, reproducing, evolving, creating an entire biosphere hidden beneath the ice of a tiny moon orbiting Saturn. The possibility is real. The conditions appear to be right, and the plumes give us direct access to ocean water without needing to drill through kilometers of ice. We can simply fly through the plumes, collect samples, and analyze what Enceladus's ocean contains. When scientists look at Enceladus's south polar terrain, they see evidence of recent and ongoing geological activity. The region is geologically young, its surface features suggesting that the ice there has been modified, melted, and refrozen relatively recently in geological terms. The terrain shows little impact cratering compared to other regions of Enceladus or other moons. Craters are the universal clock of planetary surfaces. The more craters a surface has, the older it is, because it's had more time to accumulate impact from asteroids and comets. The south polar region of Enceladus has very few craters, suggesting that something has erased them, resurfaced the area, renewed it. That something is the ongoing geological activity, the venting of material from below, the flexing and cracking of ice, the heat rising from the ocean beneath. This region isn't billions of years old like most moon surfaces. Parts of it might be only millions of years old, or even younger. Fresh ice, recently emplaced, covering over ancient craters and creating a smooth, young landscape. Despite its small size, Enceladus holds one more distinction worth noting as you drift towards sleep. Enceladus is Saturn's brightest major moon. When sunlight hits its surface, almost all of it reflects back into space. Enceladus's surface is covered in fresh, clean water ice, the freshest in the solar system, constantly renewed by the fallback of plume material. This ice is incredibly reflective, giving Enceladus an albedo, a measure of reflectivity, close to 1.0, meaning it reflects nearly 100% of the light that hits it. If you could see Enceladus with your own eyes from a nearby spacecraft, it would shine like a beacon, a brilliant white sphere against the black of space, brighter than any other moon in Saturn's system, brighter even than fresh snow on Earth. It would hurt to look at directly, this small world blazing with reflected sunlight, its icy surface pristine and pure, and all that material being vented into space, the water vapor and ice crystals shooting out from the tiger stripes, doesn't just fall back to the surface or escape into interplanetary space. Much of it goes into orbit around Saturn, spreading out along Enceladus's orbital path, creating a vast ring of tiny ice particles. Material from Enceladus feeds Saturn's E-ring, the outermost of Saturn's main ring systems, a diffuse halo of ice that extends from the orbit of Mimas out past the orbit of Dione. The E-ring is Enceladus's gift to Saturn, proof written in ice particles across hundreds of thousands of kilometers of space that this tiny moon is active, that it vents its ocean into the cosmos, that beneath its frozen exterior lies a world of liquid water, warmth, and possibility. Enceladus is small, only 500 kilometers across, a moon you could hold in your mind's eye, imagining yourself standing on one side and seeing the entire curve of the horizon. But within that small package lies one of the solar system's greatest mysteries and one of our best hopes for finding life beyond Earth. A global ocean hidden beneath ice. Hydrothermal vents, possibly teeming with chemistry, if not life itself. Plumes that give us direct access to that ocean's contents, and a geological vitality that defies the moon's size, proving that even the smallest worlds can harbor the greatest secrets. As you rest now, as your breathing slows and deepens, picture this small, bright moon, its tiger stripes venting ice into space, its ocean hidden but real, its potential profound. Somewhere beneath that ice, in the darkness and warmth, water flows. Chemistry happens, and perhaps, just perhaps, in the deepest, darkest parts of Enceladus's ocean, something lives. Let these thoughts carry you deeper into rest. Water flowing beneath ice, plumes reaching towards space, a tiny moon with an ocean of secrets. Drift now. Drift. The icy mid-sized moons. We continue our journey now through Saturn's family, visiting worlds of ice and ancient memory. Moons that hold secrets beneath their frozen surfaces. Let's explore these silent sentinels. We have met Titan, the giant among moons, a world unto itself with its thick atmosphere and methane seas. We have visited Enceladus, small but vibrantly alive, spraying its ocean into space for all to see. But between these extremes, orbiting Saturn in their orderly paths, lie several other substantial worlds. Not as large as Titan, not as dramatically active as Enceladus, but fascinating in their own quiet ways. These are Saturn's mid-sized, icy moons, and they have stories to tell if we know how to read them. What makes these moons particularly intriguing to scientists is this. Saturn's mid-sized, icy moons show evidence of past or present internal heat. When we look at their surfaces through telescope images, when we study their geology and their structures, we see signs that these worlds were not always the cold, quiet places they appear to be today. We see fractures and grooves, smooth plains that suggest ice once melted and refroze. Features that can only form when a moon's interior is warm enough to allow the ice to flow and to form. Heat is life in the geological sense. A warm moon is an active moon, a place where things happen, where ice can melt and refreeze, where tectonics can operate, where perhaps liquid water can exist beneath the frozen surface. And evidence suggests that many of Saturn's mid-sized moons may have hosted subsurface oceans at some point in their history. Picture this. Billions of years ago, when the Saturn system was young, when the moon's orbits were still settling into their final configurations, when tidal forces were stronger and orbital resonances were creating friction and heat. Back then, several of these moons may have been internally warm enough that beneath their icy crusts, layers of liquid water existed, creating temporary oceans that persisted for millions or even billions of years before gradually cooling and freezing solid. But here's the remarkable possibility that keeps scientists intrigued. Some may still maintain subsurface oceans today. We know Enceladus definitely has one. We strongly suspect Titan does as well. But what about the others? What about Dione, or Tethys, or Rhea? Could liquid water still exist beneath their surfaces, hidden beneath kilometers of solid ice, kept warm by residual heat or by ongoing tidal flexing? The evidence is tantalizing but not conclusive. Gravitational measurements suggest some unusual density distributions. Certain geological features look suspiciously young. But unlike Enceladus with its obvious plumes, these other moons keep their secrets well hidden, forcing us to theorize and model and wait for future missions that might finally answer the question: are you still alive beneath your frozen exterior, or have you gone completely cold? As you settle deeper into relaxation, consider what it means that these surfaces preserve records over 4 billion years old. For billion years, nearly the entire age of the solar system, these moons formed in the ancient disk of gas and dust that surrounded young Saturn, coalescing from countless collisions of ice particles, growing larger and larger until they reached their current sizes. And ever since then, for 4 billion years, they've been recording history. Every impact that struck their surfaces left a crater, a permanent scar, unless something came along to erase it. Every fracture that opened in their ice crusts remains visible today. Every volcanic episode, every tectonic shift, every moment of geological activity is written in the landscapes we can photograph from passing spacecraft. These moons are history books, their surfaces covered in text written in ice and rock, waiting for us to learn how to read them fully. Among these mid-sized moons, one stands out for a single dramatic feature that has captured popular imagination. Mimas is famous for its giant Herschel crater, an impact scar so large it dominates the entire moon. When you see an image of Mimas, your eye is immediately drawn to this crater, a massive circular depression with a central peak rising from its floor, looking for all the world like the Death Star from Star Wars, that fictional space station with its super laser dish. The resemblance is purely coincidental. Mimas is natural, ancient, and quite real, but it's striking nonetheless. Herschel crater is about 130 kilometers across on a moon only about 400 kilometers in diameter. That's roughly 1/3 the diameter of the entire moon. The impact that created this crater must have been catastrophic, nearly shattering Mimas entirely. Had the impactor been just slightly larger or struck with just a bit more velocity, Mimas might have broken apart completely, transforming from a single moon into a cloud of fragments that would have eventually either recoalesced or dispersed into rings around Saturn. But Mimas survived, barely, and the crater remains as testimony to that violent ancient event, a reminder that the solar system's early history was characterized by chaos and collisions, by impacts so powerful they could destroy entire worlds. Yet despite its dead-looking surface, covered in ancient craters and showing little sign of recent activity, recent research suggests something surprising. Mimas may have a subsurface ocean despite its dead-looking surface. Analysis of subtle wobbles in Mimas's rotation, measurements of how it deforms as it orbits Saturn, suggest that its interior might not be entirely solid. There may be a layer of liquid water somewhere beneath the ice, a hidden ocean that exists without any obvious surface expression, without plumes or fractures or any of the obvious signs we see on Enceladus. If confirmed, this would be profound. It would mean that oceans can exist beneath surfaces that show no obvious evidence of internal activity. It would mean that we might be systematically underestimating how many ocean worlds exist in the outer solar system, mistaking quiet exteriors for dead interiors. Mimas, with its Death Star appearance and its ancient cratered surface, might be hiding one of the most unexpected oceans in the solar system. There's another curious feature of Mimas worth noting as you drift towards sleep. Mimas is noticeably ovoid due to Saturn's gravity. An ovoid, not quite spherical, but elongated, stretched slightly in the direction of Saturn. This happens because Saturn's gravity pulls more strongly on the near side of Mimas than on the far side, creating a tidal bulge, permanently deforming the moon into an egg-like shape. When we look at Mimas, we're seeing a moon literally shaped by the planet it orbits. Its form testimony to the immense gravitational forces at play in the Saturn system. Moving outward from Mimas, we encounter another of Saturn's mid-sized moons, Tethys. Tethys is made mostly of water ice, one of the densest concentrations of pure water ice we find anywhere in the solar system. Its density is extremely low, barely higher than water itself, suggesting that rock and other heavy materials make up only a small fraction of its mass. This is essentially a giant ball of ice orbiting Saturn, frozen solid, reflecting sunlight with the pure white glow characteristic of clean water ice. Tethys has its own notable features: a giant impact basin called Odysseus Crater, and a vast canyon system called Ithaca Chasma that stretches 3/4 of the way around the moon's circumference. These features tell us that Tethys, like Mimas, has survived tremendous impacts and tectonic stresses. The Ithaca Chasma in particular suggests that at some point in the past, Tethys's interior might have refrozen and expanded, cracking the surface and creating this enormous valley. But mostly, Tethys is quiet now. It orbits Saturn every 1.9 days, moving through space in perfect synchronization with Saturn's rotation, always keeping the same face toward the planet. Its surface is ancient, covered in craters, telling us that nothing has resurfaced it in billions of years. If Tethys ever had a subsurface ocean, it's long gone now, frozen solid, leaving only the surface features as clues to its warmer past. These mid-sized moons, Mimas, Tethys, and others like Dione and Rhea that we'll touch on briefly, orbit Saturn in the heart of the moon system, in that zone where the inner regular moons maintain their orderly paths around the planet's equator. They are substantial worlds, each one large enough that if we could visit them, we would feel like we were standing on proper planetary surfaces rather than tiny asteroids. Each one has enough gravity to pull you down, to give you weight, to make the experience of standing on their icy plains feel almost normal, almost Earth-like, despite the alien landscape and the giant ringed planet hanging overhead. Dione and Rhea deserve mention here as well, though we treat them more briefly as you sink deeper into rest. Dione shows bright ice cliffs and wispy terrain on its trailing hemisphere, features that might indicate past geological activity or perhaps ongoing sublimation of ice. Rhea, Saturn's second largest moon after Titan, has a heavily cratered surface and might once have had its own ring system, though if it did, those rings are long gone now. What unites all these mid-sized icy moons is their essential nature. They are worlds of ice and memory, frozen archives of Saturn's history, possibly harboring hidden oceans beneath their ancient surfaces. They orbit in silence, catching sunlight and reflecting it back into space, their craters recording impacts from billions of years past, their fractures and grooves hinting at warmer times when ice could flow. Some may still be warm inside. Some may harbor liquid water, even now. Others have certainly gone cold, their internal heat dissipated into space long ago, leaving only frozen remnants. But each one contributes to our understanding of how planetary systems work, how moons form and evolve, how heat and cold and time shape worlds over billions of years. As you rest now, picture these quiet ice worlds circling Saturn in their eternal dance, their surfaces ancient and cratered, their interiors mysterious and possibly warm. They watch over the ringed planet in silent vigil, keeping secrets that we're only beginning to uncover, waiting patiently for the day when spacecraft return to study them more closely, to peer beneath their surfaces to discover whether water still flows in hidden oceans or whether these moons have truly gone cold and quiet forever. Breathe slowly. Let thoughts of ancient ice and hidden oceans drift through your mind. These moons orbit in silence, eternal, patient, waiting, Rhea, Iapetus, and strange surfaces. As we journey deeper into Saturn's realm, we encounter moons with mysterious faces, worlds marked by contrasts and ancient violence. Let us drift toward these strange and beautiful surfaces. In our exploration of Saturn's mid-sized icy moons, we touched briefly on Rhea, Saturn's second largest moon after Titan. But Rhea deserves more of our attention, more time to contemplate its ancient, scarred surface as we settle deeper into our restful journey through the Saturn system. Rhea has a heavily cratered surface, one of the most thoroughly impacted surfaces we've found anywhere in the solar system. When we look at images of Rhea, we see craters upon craters, impacts overlapping other impacts, large basins surrounded by smaller bowls, the entire surface saturated with the marks of billions of years of bombardment. This is what an ancient, geologically dead world looks like, a surface that hasn't been renewed or resurfaced in eons, that preserves every scar it has ever received. Picture yourself floating above Rhea, looking down at its icy terrain. Everywhere you look, circles within circles, depressions of every size from tiny pits just meters across to enormous basins hundreds of kilometers in diameter. The larger craters have raised rims and central peaks, created when the ice rebounded after the initial impact compression. The smaller craters are simple bowls, marking places where asteroids or comets struck and vaporized, leaving only these permanent dimples in the frozen landscape. Among this multitude of craters, two features stand out. Rhea hosts two enormous impact basins, collision scars so vast they dominate entire hemispheres of the moon. These aren't just large craters. They're impact structures on a scale that speaks to truly catastrophic events in Rhea's distant past. One basin, located on the moon's anti-Saturn hemisphere, shows a complex pattern of fractures radiating outward from the impact site, cracks that extend for hundreds of kilometers across Rhea's surface, frozen testimony to the violence of the collision. The other major basin shows similar complexity, with multiple concentric rings marking where shock waves rippled through Rhea's icy crust, fracturing and deforming the ice in expanding circles around the impact point. When these basins formed, probably billions of years ago, during the late heavy bombardment when the inner solar system was being pelted by asteroids and comets, the impacts must have shaken the entire moon, sending vibrations through its interior, possibly even melting some of the ice temporarily before it refroze. But Rhea has another mystery, something subtle and strange that scientists are still working to fully understand. Rhea shows faint equatorial features, possibly from ring material. Yes, Rhea might have had rings of its own at some point, a system of particles orbiting this moon the way Saturn's rings orbit the planet. The evidence is tentative, based on unusual patterns in the distribution of impacts and curious bright streaks near Rhea's equator. But if confirmed, it would make Rhea the only moon in the solar system known to have hosted its own ring system. Imagine that for a moment as you drift towards sleep. A moon with rings orbiting a planet that also has rings. Rings around rings. A nested structure of gravitational organization. Particles orbiting a moon that orbits a planet that orbits a star. The geometry of it is beautiful, elegant, a reminder that the same physical laws that create Saturn's rings can operate at different scales throughout the universe. The rings, if they existed, are gone now, either fallen back to Rhea's surface or dispersed into space. But they may have left their mark in the surface features we can still see today, faint clues to a time when Rhea was ringed, when particles of ice circled this moon in their own delicate dance. Now we journey farther out, beyond the realm of the inner moons, to a world so strange, so visually striking, that it captured humanity's imagination from the moment we first saw it clearly. This is Iapetus, the yin-yang moon, the two-toned world that seems to defy explanation at first glance. Iapetus has one bright hemisphere and one dark hemisphere. Not subtle variation, not gentle shading from one region to another, but stark, dramatic contrast. One half of Iapetus is bright, brilliant white ice reflecting sunlight with high efficiency, looking like the other icy moons we visited. But turn to face the other hemisphere, and the landscape transforms into something entirely different. A surface as dark as asphalt, as black as coal, absorbing sunlight instead of reflecting it, creating a moon that is literally two different colors. When early astronomers observed Iapetus through telescopes, they noticed something strange. The moon appeared bright at certain times in its orbit and much dimmer at other times. They couldn't understand why until better telescopes revealed the truth. Iapetus is tidally locked to Saturn, always showing the same face toward the planet as it orbits. And as it moves around Saturn, we on Earth see different sides of it. When the bright hemisphere faces us, Iapetus shines brilliantly. When the dark hemisphere is visible, the moon seems to almost disappear, its dark surface barely reflecting any light at all. But what causes this dramatic difference? Why is one hemisphere bright and one dark? For years, this was one of the great mysteries of the Saturn system. Then the Cassini spacecraft arrived and gave us our answer. The dark side comes from sweeping up dust from Phoebe's ring. Phoebe is another of Saturn's moons, a small, dark object orbiting far outside the main moon system in a retrograde orbit, meaning it orbits in the opposite direction from most of Saturn's other moons. Phoebe is likely a captured object, an asteroid or comet that wandered too close to Saturn and was captured by the planet's gravity millions or billions of years ago. And Phoebe is shedding material, creating a vast, tenuous ring of dark dust particles that orbit Saturn in the same retrograde path as Phoebe itself. Iapetus, orbiting Saturn much closer in, but still at a considerable distance, plows through this dust ring as it moves along its orbit. The dust particles, traveling in the opposite direction from Iapetus, slam into the Moon's leading hemisphere, the face that's always pointed forward in the direction of orbital motion. Over millions of years, this constant bombardment of dark material has coated the leading hemisphere, staining it black, transforming it from bright ice into a dark, dusty surface. The bright trailing hemisphere, meanwhile, the side that faces backward as Iapetus orbits, remains pristine, uncoated by Phoebe's dust, reflecting sunlight as clean water ice should. The result is a moon split down the middle, half bright and half dark, like a cosmic symbol of balance and duality. This explanation is elegant and supported by observations, but there's more to the story. Once the dark material started coating the leading hemisphere, it created a feedback loop. Dark surfaces absorb more sunlight and heat up more than bright surfaces. As the dark regions warmed, ice began to sublimate, to evaporate directly from solid to gas, and migrate to cooler regions. This migration further darkened the already dark areas and brightened the already bright areas, enhancing the contrast, sharpening the boundary between light and dark. The result is the striking world we see today, a moon that teaches us how orbital mechanics and surface processes can interact over geological time to create patterns that seem almost designed, almost artificial, but which arise purely from natural physical laws. Iapetus orbits far from Saturn compared to most large moons, while moons like Rhea, Dione, and Tethys orbit within a few 100,000 kilometers of Saturn. Iapetus follows a path more than 3.5 million kilometers from the planet. At that distance, it takes Iapetus 79 Earth days to complete one orbit, nearly 3 months to circle Saturn once. From Iapetus' surface, Saturn would appear much smaller than it does from the inner moons, a bright ringed object hanging in the sky, but not dominating the entire heavens as it does when viewed from Enceladus or Mimas. And Iapetus is substantial, about 1,436 kilometers in diameter, making it Saturn's third largest moon after Titan and Rhea. It's large enough to have pulled itself into a roughly spherical shape under its own gravity. Though interestingly, it shows a pronounced equatorial ridge that makes it look somewhat like a walnut, a feature whose origin remains mysterious and debated. What Rhea and Iapetus share, despite their differences, is this: these moons show dramatic surface contrasts. Rhea's contrasts are more subtle. The bright ice cliffs against darker crater terrain, the enormous impact basins against more lightly cratered regions. Iapetus contrasts are impossible to miss. The stark boundary between brightness and darkness, light and shadow, made permanent in ice and dust. These contrasts aren't random. They're not artistic choices made by some cosmic designer. Instead, surface appearance often reflects orbital history. Where a moon orbits determines what it encounters, what material it sweeps up, what radiation it receives. How fast it orbits affects tidal heating and geological activity. Whether it's locked in resonance with other moons determines whether it experiences orbital changes that might create or erase surface features. Every moon's surface is a record of its journey through time and space. Iapetus looks the way it does because it orbits where it orbits, sweeping through Phoebe's ring, experiencing the particular balance of sunlight and shadow that characterizes its distant location. Rhea looks the way it does because it's remained geologically inactive for billions of years, preserving every impact, every event in its icy surface. This leads us to a profound realization as you settle deeper into rest. Even inactive moons record ancient events. A geologically dead moon isn't uninteresting. Far from it. It's a library, a museum, a historical archive preserving events from the solar system's youth. Active moons like Enceladus erase their history, constantly resurfacing, keeping only the most recent records. But quiet moons like Rhea and the bright hemisphere of Iapetus remember everything, holding on to their scars and stories across billions of years. When we study these ancient surfaces, we're looking back in time. We're seeing the solar system as it was 4 billion years ago, when impacts were common, when debris still cluttered the space between planets, when the final stages of planetary formation were playing out in violence and collision. These moons are witnesses, silent observers who watched it all happen and preserve the evidence for us to discover. As you drift now toward deeper sleep, picture these strange surfaces. Rhea, covered in craters, bearing 2 enormous scars from impacts that nearly destroyed it. Iapetus, split between light and darkness, half-coated in dust from a distant moon's ring. A cosmic yin-yang symbol rotating slowly in space. Each surface tells a story. Each contrast reveals history. Each moon, even in silence, even in apparent inactivity, speaks to those patient enough to listen. Let these images fade gently, craters dissolving into darkness, the boundary between light and shadow blurring. Rest now in the knowledge that even stillness holds memory, even silence preserves stories. Hyperion, the weirdest moon. Now we encounter something truly bizarre, a moon that defies the orderly patterns we've seen, a world that tumbles and spins in chaotic dance. Drift with me to meet Hyperion. In our journey through Saturn's family of moons, we've seen many wonders. We've visited worlds with oceans and atmospheres, moons split between light and darkness, ancient surfaces covered in impact craters. But now we come to something different, something that stands apart from all the others, not just in its appearance, but in its very nature, in the fundamental way it moves through space. This is Hyperion, and it is, without exaggeration, one of the strangest objects we've ever encountered in the solar system. Let's begin with what strikes you immediately when you see an image of Hyperion. The moon has an extremely irregular, sponge-like shape. Forget the smooth spheres we associate with larger moons. Forget even the potato-shaped forms of small, irregular satellites. Hyperion looks like a sponge, or perhaps like a piece of pumice or a chunk of cosmic Swiss cheese. Its surface is covered in deep, irregular craters and pits that give it a porous, honeycomb appearance unlike anything else we've seen. The moon itself is lumpy and asymmetrical, measuring roughly 360 kilometers at its longest dimension but much narrower in other directions. There's no elegant geometry here, no spherical form born of self-gravity. Hyperion is a fragment, a piece of something larger, or perhaps a loose agglomeration of smaller pieces that never quite managed to pull themselves into a unified whole. When the Cassini spacecraft flew close to Hyperion and captured detailed images, scientists were startled by what they saw. The craters weren't normal bowl-shaped depressions. They were deep, steep-sided pits, some of them plunging hundreds of meters into the moon's interior. Their walls nearly vertical, their floors often darker than the surrounding terrain. The whole moon looked porous, as if you could poke your finger through the surface into empty space beneath. And that impression isn't far from the truth, because Hyperion has a very low density. Density is mass divided by volume. How much stuff is packed into a given space? Most icy moons have densities around 1 gram per cubic centimeter, roughly the density of water ice. Rocky objects are denser, around 3 or more grams per cubic centimeter. But Hyperion's density is only about 0.54 grams per cubic centimeter, barely half the density of water ice. How is this possible? How can a moon made of ice and rock be less dense than the ice itself? The answer reveals something remarkable about Hyperion's internal structure. Its porosity exceeds 40%. 40% of Hyperion's volume isn't solid material at all. It's empty space, voids, gaps, caverns, a three-dimensional maze of hollows running through the moon's interior. Imagine a moon that's more air than substance, a loose pile of rubble held together by weak gravity, filled with vacuum pockets and chambers. This isn't a solid object like Earth or even like other moons. It's a rubble pile, a gravitational aggregate, a collection of fragments that happen to be orbiting Saturn together as a single object. This porous structure explains the strange appearance of the craters. When something impacts Hyperion, instead of creating a clean, bowl-shaped crater in solid ice, the impact energy propagates through the porous structure, creating deep, irregular pits that expose the internal voids. The dark material at the bottom of many craters might be older, more organic-rich material from deeper in Hyperion structure, or simply shadows in pits so deep that sunlight never reaches their floors. But Hyperion's strangeness extends far beyond its appearance and structure. The moon's behavior, the way it moves through space, is unique in the solar system. Hyperion tumbles chaotically through space. Most moons, as we've discussed, are tidally locked to their parent planets. They rotate once per orbit, always keeping the same face toward the planet they circle. This is the stable configuration, the state that moons naturally settle into over time due to tidal forces. Earth's moon does this. Most of Saturn's moons do this. It's the normal, expected behavior. But Hyperion doesn't do this. Hyperion tumbles. It rotates in a complex, unpredictable way, spinning around multiple axes simultaneously, its orientation changing constantly. It has no stable north or south pole. In fact, the very concept of Hyperion's poles is meaningless because the moon isn't rotating in any regular way around a fixed axis. Hyperion is not tidally locked like most moons. Instead, it exists in what scientists call chaotic rotation. Chaotic here has a specific mathematical meaning. It means the rotation is sensitive to initial conditions, that tiny changes in Hyperion's orientation or spin rate lead to completely different rotational states over time. You cannot predict how Hyperion will be oriented a few months from now, even if you know its exact position and rotation today, because the system is fundamentally unpredictable. This happens because of Hyperion's irregular shape combined with its orbital location. Hyperion orbits near several of Saturn's other moons, experiencing gravitational tugs from multiple directions. Its asymmetric shape means that different sides experience different gravitational forces depending on how the moon is oriented. The combination of these factors, irregular shape, multiple gravitational influences, and the right orbital distance, creates a situation where stable rotation is impossible. Instead, its rotation is unpredictable over time. Hyperion might be spinning one way today, tumbling end over end in a particular pattern, but next month it might be rotating completely differently. There's no rhythm to it, no regularity, no way to say this is Hyperion's day length because Hyperion doesn't have a day in any meaningful sense. As you settle deeper into rest, try to picture this bizarre moon tumbling through space, rotating in its chaotic way, never settling into a stable spin, forever tumbling like a cosmic football thrown without a spiral, wobbling and rotating unpredictably as it orbits Saturn. But Hyperion has one more surprise, one final strange property that sets it apart from almost every other object we've studied. Hyperion has a statically charged surface. When the Cassini spacecraft flew past Hyperion, its instruments detected something unexpected. The moon's surface carries a significant electrical charge, like a balloon rubbed on hair, or the static you feel touching a doorknob in winter. This happens because Hyperion orbits within Saturn's magnetosphere, the region of space dominated by Saturn's magnetic field. Charged particles trapped in this field constantly bombard Hyperion's surface. Normally, these particles would be conducted away into space, but Hyperion's surface is made of insulating materials, water ice, and organic compounds that don't conduct electricity well. So the charge builds up, accumulating on the surface until Hyperion becomes essentially a giant static electricity generator floating in space. This is extraordinarily rare. In fact, Hyperion is the only known object besides Earth's moon with this property. Our moon also accumulates static charge, particularly in permanently shadowed craters near its poles where sunlight never strikes and charged particles from the solar wind build up over time. But among planetary satellites in the outer solar system, Hyperion is unique in having this measurable surface charge. If you could somehow stand on Hyperion's surface, stepping carefully across its spongy, crater-pocked terrain, you might feel the static electricity in the dust particles jumping and clinging to your suit. The very ground beneath your feet would be electrically charged, a subtle but real effect of the moon's interaction with Saturn's magnetic environment. When we step back and consider everything we've learned about Hyperion, its sponge-like appearance, its incredibly low density, its porous internal structure, its chaotic tumbling rotation, its statically charged surface, we're forced to conclude that Hyperion is one of the strangest moons in the solar system. It doesn't behave like other moons. It doesn't look like other moons. Its very structure is fundamentally different from the solid, coherent bodies we're used to thinking about when we picture planets and satellites. Hyperion is a reminder that the solar system is full of objects that defy our expectations, that challenge our categories, that force us to expand our understanding of what's possible. Perhaps Hyperion is a fragment of a larger moon that was shattered in a collision billions of years ago. Perhaps it's a collection of smaller objects that gathered together but never quite merged into a single coherent body. Perhaps it's what happens when you build a moon in just the right location, with just the right composition, under just the right conditions to create something utterly unique. We don't know for certain. Hyperion keeps its secrets, tumbling through space in its chaotic dance, its porous interior hidden beneath a surface riddled with deep, mysterious pits. It orbits Saturn every 21 days, forever tumbling, forever charged, forever strange. And as we leave Hyperion behind, continuing our journey through Saturn's realm, we carry with us the knowledge that even in a system with 274 moons, even among all that diversity and wonder, there is room for something truly exceptional. There is room for a moon so strange, so unlike anything else, that it reminds us how much we still have to learn, how many surprises still await us in the darkness of space. Hyperion tumbles on through the void, chaotic and porous, and charged with static electricity, a cosmic oddity orbiting the great ringed planet, unique among all the moons we know. Let this strange moon tumble through your thoughts, spinning without rhythm, charging with energy, until it too fades into the peaceful darkness of deep rest. Breathe slowly, drift, let go. Captured moons and cosmic debris. We journey now to the far reaches of Saturn's realm, to the outer darkness where captured wanderers orbit, worlds that came from beyond. Let us drift among these cosmic exiles. In our exploration of Saturn's moon system, we spent most of our time among the inner moons, the regular satellites that orbit close to Saturn, aligned with its equator, moving in orderly circular paths. These are Saturn's natural children, born from the same disk of gas and dust that formed the planet itself, condensing and growing in place billions of years ago. But they represent only a small fraction of Saturn's total moon count. The truth is that many of Saturn's outer moons are irregular and likely captured objects. They didn't form alongside Saturn. They weren't born in the neat, orderly disk that produced the inner moons. Instead, they wandered in from elsewhere, from the asteroid belt, from the Kuiper belt beyond Neptune, from interplanetary space, and happened to pass close enough to Saturn that the planet's gravity caught them, pulled them into orbit, and held them as permanent prisoners in the outer reaches of the moon system. These captured moons are different in almost every way from their inner cousins. Their orbits are strange, tilted, elongated. Their compositions are different, often darker, more primitive, preserving material from the early solar system that hasn't been processed and modified by proximity to a warm planet. And in many cases, some orbit Saturn in a retrograde direction, meaning they circle the planet backward, moving opposite to the direction of Saturn's rotation and opposite to the orbital motion of the regular inner moons. Retrograde orbits are a telltale sign of capture. When moons form naturally in a disk around a planet, they all orbit in the same direction, the direction the disk was rotating. But an object captured from interplanetary space can have any orbit depending on the direction it was traveling when Saturn's gravity grabbed it. If it happened to be moving generally opposite to Saturn's rotation, it would end up in a retrograde orbit, forever moving the wrong way against the flow of the rest of the system. Among these captured objects, one stands out for its size and importance. Phoebe is a captured object from the Kuiper Belt, that distant region of the solar system beyond Neptune, where countless icy bodies orbit in the cold and dark. Phoebe is about 200 kilometers across, substantial enough to be roughly spherical, large enough to have its own geology and history, but still small compared to the major moons we visited. Phoebe orbits Saturn in a retrograde direction, taking about 550 days, more than a year and a half, to complete one orbit. Its path is highly inclined, tilted at about 175 degrees relative to Saturn's equator. It's dark, much darker than the icy inner moons, with a surface that reflects only about 6% of the light that hits it. This darkness comes from its composition. Phoebe is rich in organic compounds, primitive materials from the outer solar system that give it a charcoal-like appearance. We've already met one consequence of Phoebe's presence in our earlier discussion of Iapetus. Phoebe supplies dark material to Iapetus, creating the vast, tenuous ring of dust that Iapetus sweeps through in its orbit. Phoebe is constantly being eroded by impacts by the solar wind, by radiation, shedding tiny particles that spread out along its orbital path. This dust ring, called the Phoebe ring, extends for millions of kilometers and is largely invisible except in infrared light. But it's real and substantial enough to have coated an entire hemisphere of Iapetus over billions of years. Phoebe represents a messenger from the outer solar system, a sample of Kuiper Belt material delivered to Saturn's doorstep and held there for our study. When we analyze Phoebe's composition, when we study its surface and structure, we're learning about the materials that exist in the distant reaches beyond the major planets, in that cold realm where the sun is barely brighter than other stars. But Phoebe is just one of many captured objects. The irregular moons orbit far from Saturn, much farther than any of the regular moons. While moons like Titan orbit at around 1 million kilometers from Saturn, and even distant Iapetus orbits at about 3.5 million kilometers, the irregular moons can be found at distances of 10, 15, even 20 million kilometers from the planet. At these distances, Saturn's gravitational influence is weak, barely strong enough to hold onto these wandering objects. Their orbits are highly inclined and eccentric. Inclined means tilted. Some irregular moons orbit at angles of 30, 40, even 50 degrees or more relative to Saturn's equator. Eccentric means elongated. Instead of circular orbits, they follow elliptical paths that bring them much closer to Saturn at some points in their orbit and carry them far away at others. These are not the neat, stable, circular orbits of the inner moons. These are chaotic, wild orbits, the signatures of objects that were captured rather than formed in place. And here's where our story connects to the recent discoveries we discussed earlier. The 128 newest moons announced in 2025 are all classified as irregular moons. Every single one of them orbits in the outer reaches of Saturn's gravitational domain, following inclined and eccentric paths, many in retrograde orbits. These are the newly discovered members of Saturn's extended family. The tiny captured objects that had eluded detection until modern telescopes and sophisticated image stacking techniques revealed their faint glimmers against the background stars. These moons are only a few kilometers across. Some might be as small as 2 or 3 kilometers in diameter. Objects you could walk around in a few hours, tiny fragments of rock and ice tumbling through the darkness at the edge of Saturn's influence. At this size, they're not spherical. They're irregularly shaped chunks, cosmic debris held in orbit by Saturn's gravity, but barely massive enough to hold themselves together. Because they orbit so far from Saturn, many have orbital periods longer than 1,000 days. Think about that. More than 3 years to orbit Saturn just once. Some of the most distant, irregular moons take 4, 5, even 6 years to complete a single orbit. These are not moons in any conventional sense. They're more like very distant satellites, barely bound to Saturn, orbiting at the very edge of the planet's gravitational reach. If you were standing on one of these distant, irregular moons, looking back towards Saturn, the planet would appear as just a bright point of light, its rings barely visible even through a telescope. You would be so far from the sun that daylight would be dim, twilight-like, providing just enough illumination to see by, but not enough to feel any warmth. And you would be profoundly alone, orbiting in the cold darkness, your tiny moon taking years to slowly circle the distant planet. The properties of these irregular moons suggest a violent past. Their compositions vary, suggesting they came from different regions of the solar system. Their orbital groupings, clusters of moons with similar orbits, suggest that some of them are fragments from larger objects that were shattered in collisions after being captured by Saturn. The solar system's early history was violent, filled with impacts and near misses, with objects careening through space and smashing into one another. When Saturn captured a larger object, perhaps something hundreds of kilometers across, that object might have orbited for millions of years before colliding with another captured moon or being struck by an asteroid. The impact would shatter it, breaking it into dozens or hundreds of smaller fragments. But Saturn's gravity would hold onto those fragments, keeping them in roughly the same orbit as the parent body, creating a family of related moons all following similar paths around the planet. Scientists have identified several such families among Saturn's irregular moons. Groups of small satellites with very similar orbital characteristics, almost certainly the shattered remnants of larger parent bodies. Each family is a frozen record of an ancient collision, a violent event that happened millions or billions of years ago, but which left its signature in the orbits of the fragments that survived. As you drift deeper into sleep, picture this vast outer realm of Saturn's moon system, close to the planet. The regular moons orbit in their orderly paths, aligned and synchronized. But far beyond, in the darkness at the edge of Saturn's gravitational domain, a cloud of irregular moons tumbles through space. Some orbit forward, some backward. Some follow highly tilted paths that take them high above and far below Saturn's equatorial plane. Some are lone travelers, while others move in clusters, fragments of parent bodies long since destroyed. These are the captured moons, the cosmic debris, the wanderers that came from elsewhere and were caught by Saturn's gravity. They represent samples from across the solar system, bits of the asteroid belt, pieces of the Kuiper belt, fragments of ancient collisions. Each one has a story, though we may never know most of those stories in detail. Each one is a messenger from some distant place and time, now held forever in orbit around the Great Ring planet. The 128 new moons discovered in 2025 are just the latest additions to this population. There are almost certainly more waiting to be found, fainter, smaller, more distant objects that current telescopes cannot yet detect. Every few years, as technology improves, as telescopes become more sensitive, as image processing techniques advance, we find more of them. The count grows, the census expands, and our understanding of Saturn's extended family deepens. These irregular moons remind us that planetary systems are not static, closed environments. They interact with their surroundings, capturing passing objects, accumulating debris, growing their families through gravitational acquisition as well as through natural formation. Saturn's 274 known moons include both kinds: the children born in place and the wanderers adopted from afar. And in the farthest reaches where sunlight is dim and Saturn is just a bright star among stars, the irregular moons continue their slow, patient orbits. Years pass with each circuit. Centuries accumulate. The moons tumble through the darkness, preserving in their composition and orbits the evidence of the solar system's violent youth, silent witnesses to events billions of years past. Let these distant moons fade from your thoughts now, orbiting in darkness, taking years to circle their planet, drifting through the cold reaches of space. As you drift deeper into sleep, peaceful, quiet, at rest. Collisions, clues, and the future. We come now to the end of our journey, where past violence meets future discovery, where fragments tell stories and mysteries await. Settle into this final chapter as we contemplate what Saturn's moons reveal. Throughout our exploration of Saturn's magnificent family of 274 known moons, we've encountered world after world, each with its own character and story. We've seen the grandeur of Titan, the active plumes of Enceladus, the two-toned face of Iapetus, the chaotic tumbling of Hyperion, and the distant orbits of captured irregular moons. But now, as we prepare to rest, we must ask, what do all these moons tell us? What larger story emerges from this collection of ice and rock orbiting Saturn? The answer begins with violence. Statistical studies suggest irregular moons formed from collisions. When scientists analyze the orbits, sizes, and compositions of Saturn's outer moons, they find patterns. Not random distribution, but clustering, groupings that indicate common origins. These patterns tell us that the irregular moon population we see today is not the same population that existed billions of years ago. The outer reaches of Saturn's moon system have been shaped by impacts, by catastrophic collisions that shattered larger bodies into the fragments we observe today. One particular grouping stands out in this analysis. Many cluster near the Mundilfari subgroup. Mundilfari is one of Saturn's irregular moons, about 7 kilometers across, orbiting in a retrograde direction at a distance of nearly 19 million kilometers from Saturn. But Mundilfari is not alone. It's surrounded by a family of similar moons, all following nearly identical orbits, all roughly the same size, all with compositions suggesting they share a common heritage. This clustering indicates a shattered parent moon. At some point in the relatively recent past, recent by geological standards, there was a larger moon orbiting Saturn in this region. It might have been 50 kilometers across, or 100, or even more. It followed an orbit similar to the ones we see in the Mundalfari group today. And then something struck it, another irregular moon, perhaps, or an asteroid passing through the outer solar system. The collision was catastrophic, energetic enough to completely destroy the parent body, breaking it into dozens or hundreds of smaller pieces. When scientists model this collision, when they calculate the energies involved, they find that fragments were ejected at speeds over 200 meters per second. Picture the impact. A catastrophic smash that instantly vaporizes part of the parent moon and sends the rest flying outward in a cloud of debris. 200 meters per second might not sound fast compared to spacecraft velocities or the speed of light, but for chunks of rock and ice, it's violent, energetic, more than enough to scatter fragments across thousands of kilometers of space. But here's what's remarkable. Even at those speeds, Saturn's gravity was strong enough to hold onto the fragments. Instead of escaping into interplanetary space, instead of being lost forever, the pieces remained in orbit around Saturn. Their orbits are similar because they all started from roughly the same location when the parent body shattered. Over time, those orbits have diverged slightly due to gravitational perturbations from other moons and from the Sun, but they remain clustered, moving together like a flock of birds, a family of fragments forever bound to their orbital path. And here's the truly intriguing part. The collision likely occurred within the last 100 million years. 100 million years sounds like a long time, and it is by human standards. But in the 4.5 billion year history of the solar system, 100 million years is recent, almost contemporary. The dinosaurs went extinct 66 million years ago. 100 million years ago on Earth, we were in the middle of the Cretaceous period, with dinosaurs still dominant and the first flowering plants just beginning to spread. In cosmic terms, this collision happened yesterday. And we can tell because the fragments haven't had time to disperse widely yet, haven't had time for their orbits to evolve into completely different configurations. The clustering is still tight, still obvious, preserving the signature of that ancient but relatively recent catastrophe. This scenario is supported by another observation. The high number of tiny moons supports this collision hypothesis. When a large moon shatters, it doesn't break into a few large pieces. It creates a cascade of fragments in all sizes. A few larger chunks, more medium-sized pieces, and many, many small fragments. The size distribution follows a predictable pattern based on the physics of catastrophic impacts. And when we look at Saturn's irregular moon population, we see exactly this pattern. There are a few larger irregular moons like Phoebe, measured in hundreds of kilometers. There are more moons in the tens of kilometers range. And there are many, many small moons only a few kilometers across. The 128 new moons discovered in 2025 are almost all in this smallest category. The debris, the fragments, the cosmic shrapnel created when larger bodies were destroyed. This tells us that collisions have been shaping Saturn's outer moon system throughout its history and continue to shape it today. The irregular moons are not as stable, unchanging population. They collide with each other, break apart, create new fragments, and occasionally lose pieces that escape Saturn's gravity or fall inward and are destroyed. It's a dynamic environment, violent on long timescales, constantly evolving. But we must recognize our limitations. Current surveys are near their detection limits. The telescopes and techniques that found the 128 new moons in 2025 are operating at the edge of what's possible with current technology. The smallest, faintest moons we can detect now are roughly 2 to 3 kilometers across. And even those require years of patient observation and sophisticated image processing to reveal. There are almost certainly smaller moons orbiting Saturn, fragments 1 kilometer across, or 500 meters, or even smaller. But they're too faint, too small, too distant for us to detect yet. They're out there, orbiting in the darkness, invisible to our current instruments, but real nonetheless. This is where the future comes in. Future telescopes may reveal thousands more moons. The next generation of astronomical instruments, larger telescopes with more sensitive cameras, advanced image processing powered by artificial intelligence, space-based observatories free from Earth's atmospheric distortion. We'll be able to detect much fainter objects than we can see today. When these instruments come online, when we turn them towards Saturn and begin systematic surveys of its outer moon system, we may find that the 274 known moons are just the beginning. There might be 500 moons, or 1,000, or even more if we count every fragment larger than a few hundred meters. The definition of moon may need to evolve. At what size does a fragment stop being a moon and become just a piece of orbital debris? Is a boulder 100 meters across orbiting Saturn moon? What about 50 meters? 10? These are questions we'll need to answer as our detection capabilities improve and we discover more and more of these tiny objects. But regardless of how many moons we eventually find, one truth remains constant. Saturn's moons preserve a record of solar system history. Each cratered surface is a historical document recording the bombardment rate in different epochs. Each composition reveals something about the materials that existed in different regions of the early solar system. Each orbit tells us about gravitational interactions and resonances and the slow evolution of the Saturn system over billions of years. The regular inner moons preserve evidence of Saturn's formation, of how the planet's disk of gas and dust condensed into worlds. The irregular outer moons carry samples from the asteroid belt and Kuiper belt, telling us about conditions in those distant regions. The shattered families of fragments record collisions, documenting the violent processes that continue to shape planetary systems long after their initial formation. And finally, studying them helps explain how planets and moons evolve. Saturn's moon system is a laboratory, a natural experiment in planetary science that we can observe and analyze. By understanding how these moons formed, how they interact, how they change over time, we learn principles that apply not just to Saturn, but to all planetary systems, including systems around other stars where planets will never visit are accompanied by moons we'll never see directly. Every discovery at Saturn, every new moon detected, every plume analyzed, every ocean discovered, adds to our understanding of how worlds work, how they form, how they live and die. When we study Enceladus's ocean, We learn about the conditions that might support life. When we analyze Titan's atmosphere, we gain insights into prebiotic chemistry. When we catalog irregular moons and their collision families, we understand the violence that shapes planetary systems. As you rest now, as your breathing slows and your mind drifts towards sleep, let yourself contemplate the vastness of what we've explored. 274 known moons, each one a world, each one with its own story. Some are ancient and cratered, preserving surfaces billions of years old. Some are young and active, venting water into space or renewing their surfaces through geological processes. Some are large enough to have atmospheres and oceans. Some are tiny fragments, barely held together by their own weak gravity. They orbit Saturn in a complex dance, some close, completing orbits in hours or days, others distant, taking years to circle the ringed planet once. Some move in orderly, circular paths aligned with Saturn's equator. Others follow wild, eccentric orbits, tilted and elongated, traveling backward in retrograde motion. Some are tidally locked, always showing the same face to Saturn. Others tumble chaotically, their rotation unpredictable and strange. Together, they form the largest and most diverse moon system in the solar system, a kingdom of ice and rock presided over by Saturn, the Moon King. And we, from our small blue world orbiting the sun far from Saturn's realm, have only begun to explore this magnificent family. Each year brings new discoveries. Each advance in technology reveals fainter moons, smaller fragments, deeper secrets. The journey continues. The count grows, and somewhere out there, in the darkness beyond even the most distant moon we've yet discovered, there may be more fragments waiting, more pieces of Saturn's extended family orbiting in silence, patient and eternal, waiting for the day when human eyes finally notice their faint reflected sunlight and welcome them into our catalog of known worlds. Rest now. Let all these moons drift through your thoughts like stars. 274 worlds, each one unique, each one part of something larger, orbiting forever in the darkness. As you orbit into sleep, peaceful, complete, at rest. The journey is finished. The moons continue their dance, and you can finally, simply rest. Rest among the moons. And so our journey through Saturn's realm comes to a gentle close. As you drift in the peaceful darkness, let these final thoughts settle over you like stardust. We have traveled far together tonight, drifting through the kingdom of the Moon King, visiting 274 known worlds, each one a marvel, each one a testament to the beauty and complexity of our solar system. From Titan's methane seas to Enceladus's hidden ocean, from Iapetus' two-tone face to Hyperion's chaotic tumble, from ancient cratered Rhea to the distant captured wanderers in the outer darkness. We've witnessed wonders that few could have imagined before spacecraft ventured to Saturn's realm. These moons continue their eternal dance even now as you rest. They orbit in silence, in patterns both orderly and chaotic, preserving their secrets, waiting for humanity to return and explore.